Welcome back to D-Machine, the place where we explore the hidden craftsmanship behind the world's heaviest and hardest working machines. Today, we're stepping inside a factory in China where enormous industrial springs are built. Springs so strong, they help carry the weight of mining equipment, rail systems, and massive construction machines. These springs don't just appear out of nowhere. Their journey begins as simple steel bars and ends as precision-engineered components, shaped by heat, pressure, and generations of industrial knowledge. In this video, we'll walk through each stage of the process, from raw material to finished spring, and discover how heavy industry engineering still relies on both modern technology and skilled human hands. Every giant spring begins with raw steel bars specifically chosen for their exceptional elasticity, tensile strength, and long-term fatigue resistance. These properties are critical because once the spring is in service, often inside heavy machinery, it must endure millions of compression cycles without cracking. Overhead gantry cranes lift the steel bars into position, a familiar sight in older industrial yards across Asia. From here, the bars enter a large horizontal bandsaw, where each piece is cut to a precise working length. This step has to be accurate, because even a small deviation can affect how evenly the spring coils later on. A stream of cooling foam surrounds the blade, reducing heat buildup and preventing micro cracks in the metal as the saw slices steadily through the hardened steel. Before these steel bars can be coiled into massive industrial springs, their ends must be properly formed. Each cut bar is fed into a high-temperature furnace, where it is heated to a bright orange glow, typically above 1,000 degrees Fahrenheit. At this temperature, the steel becomes more malleable, allowing it to be shaped without causing internal stress. The red-hot bars then pass through a set of heavy forging rollers. These rollers compress and taper the end of the steel, a process known as end forging or upsetting. This step plays an important role later. The tapered end reduces grinding time during final finishing and minimizes material waste. More importantly, it helps the spring coil start cleanly and uniformly, improving durability and overall performance in heavy-duty applications. Once the forged ends are prepared, each steel bar is loaded into a long heating furnace for its most critical transformation. Inside this chamber, the temperature climbs high enough to soften the entire length of the steel, often reaching more than 1,600 degrees Fahrenheit. At this stage, the grain structure of the metal changes, becoming far more flexible and suitable for forming. Workers guide the glowing bar out of the furnace with long tongs, a technique that hasn't changed much in decades. Despite the modern equipment, this part of the process still depends heavily on skilled hands and experience. Timing is everything. If the steel cools even slightly, it becomes too rigid to shape properly. While still bright orange, the softened bar is fed directly into a powerful coiling machine. The rotating mandrel bends the red-hot steel around a fixed form, creating the familiar spiral shape of a spring. Each rotation must be consistent, because even a small variation in coil spacing can affect the spring's performance and load capacity. Once the massive steel spring has been coiled into shape, it must be hardened, a crucial step to ensure it can survive the extreme stresses it will face in service. Still glowing at nearly 2,000 degrees, the spring is guided into a quenching tank, filled with specialized industrial oil. The sudden drop in temperature locks the steel's internal grain structure into a much harder, higher strength form. This rapid cooling, known as quenching, has been used in factories around the world for more than a century. As the spring sinks beneath the surface, clouds of vapor rise and the metal darkens instantly, signaling the transformation happening within. After quenching, the hardened springs are lifted out and inspected, but they're still too brittle to be used safely. The next step will restore the toughness they need. After heat treatment, the spring is strong but still far from ready. The next crucial step is end grinding, a process that ensures the spring can sit perfectly level once installed. A massive industrial grinder clamps the hardened coil and slowly rotates it against a high-speed abrasive wheel. As sparks fly, the machine removes the uneven material created during forging and quenching, flattening each end with remarkable precision. A poorly ground end can cause the spring to tilt, concentrate stress, and eventually fail. In heavy machinery, especially mining and construction equipment, Such a failure can be catastrophic. That's why factories dedicate so much care to getting this part right. What was once a rough, scale-covered piece of steel now begins to show the clean, bright surfaces that mark a properly finished industrial spring. After grinding, the spring looks complete, but its internal structure still holds residual stress from forging, coiling, and heat treatment. If left untreated, those stresses can cause premature deformation or even failure. To prevent this, each spring undergoes a full compression test, known as stress relief. The massive coil is placed under a hydraulic press and compressed nearly to its design limit. This controlled deformation forces the steel's grain structure into a stable, predictable state. Once released, the spring's free height is measured carefully. In heavy-duty applications, consistency is everything. After stress relief, the springs still carry oxide scale and surface imperfections. To prepare them for real-world use, the coils are hung on racks and moved into a shot-blasting chamber. Thousands of steel pellets strike the surface at high speed, stripping away scale and leaving behind a clean, uniform finish. More importantly, this process induces a layer of beneficial compressive stress on the surface, dramatically increasing fatigue life and helping the spring survive millions of load cycles. When the chamber doors open, the springs emerge darker, smoother, and with a strengthened surface, ready for final finishing. Each coil is placed into a computerized load testing machine, where it's compressed under controlled pressure. The system records stiffness, deformation, and return height, ensuring the spring behaves exactly as designed. Next comes magnetic particle inspection. Under ultraviolet light, a fluorescent magnetic powder reveals microscopic cracks that cannot be seen with the naked eye. Only springs that pass both tests move forward, because even a hairline defect can cause catastrophic failure in heavy equipment. With all structural testing complete, the final step is to protect the spring from the elements. Even the strongest steel is vulnerable to moisture and corrosion, especially in outdoor or heavy-duty environments. Workers apply a thick anti-corrosion coating, either by brushing or dipping, ensuring that every curve of the coil is fully covered. Once cured, the finish forms a durable shield that greatly extends the spring's service life. The coated springs then move through a drying chamber, where warm, circulating air hardens the surface and gives the steel its deep, uniform color. The transformation from raw forged metal to a sleek industrial component is immediately visible. The surface becomes smoother, more refined, and ready for long-term operation. Finally, each spring is carefully wrapped in protective cushioning to prevent damage during transport. Workers stack the completed coils on wooden pallets, securing them with straps for stability. These massive springs may weigh hundreds of pounds each, yet they must arrive at their destination in perfect condition, ready to be installed in rail systems, mining equipment, or large-scale mechanical assemblies. If you enjoyed this journey inside the factory floor, make sure to subscribe to D-Machine. There are countless stories in the world of machinery, and we're here to bring them to life. Thank you for watching.